Hello everyone, this is Siddiqur Rahman and welcome to the 7th lecture of the second week. So let's start. By the end of this lecture, you guys will be able to know, or you guys will learn first complement as well as second complement. So let's move into the next slide. This slide represents the overall scenario of this lecture, and you can say the end lecture of the second week. So you guys may learn from this lecture complement as well as types, and the overview of binary system complement, overview of ones complement, and you can learn one of the example of ones complement. Then you can learn the overview of second complement or two's complement, and you can learn the example of two's complement. So let's start with the overview of complement and types. So let's move into the next slide. From this slide you may learn what is complement and the classification of complement. So let's start with the definition of complement. Complements are used in the digital computers in order to simplify the subtraction operation and for the logical manipulations. For each radix, which is symbolized by R system, radix R represents base of the number system. We already know that. So there are two types of complements. Well, in this slide, this table represents the classification of the types. In this slide, this table represents the classification of the complement. First one is radix complement and second one is diminished radix complement. The description of radix complement is the radix complement is referred to as the R's complement, and the description of diminished radix complement is the diminished radix complement is referred to as the R minus 1's complement. So let's move into the next slide. From this slide you may learn what is binary system complement. So let's start. Binary number system is one of type binary number system is one of the type of most popular number representation techniques that used in digital systems. Remember these things. In the binary system there are only two symbols or possible digit values. One is 0, which is symbolized or designated by off, and 1, and another one is 1, which is designated by on. Well, represented by any device that only two operating states or possible conditions. Next, generally there are two types of complement of binary number. One is ones complement and another one is two's complement. To get ones complement of a binary number, simply invert the given number. For example, ones complement of binary number 110010 is 001101. To get two's complement of binary number is ones complement of given number plus 1 to the least significant bit, which is in short LSB. For two's complement of a binary number 10010 is 01101 plus 1, which is 01110. Next, from this slide you may learn what is ones complement. So let's start. There are simple algorithm to convert a binary number into ones complement. To get ones complement of a binary number, simply invert the given number. You can simply implement logic circuit using NOT gate for each bit of binary number input. Implementation of logic circuit of 4-bit ones complement is given as following below. Well, this figure is represented a representation of 4-bit ones complement logic circuit, and we already indicated this symbol is represented at NOT gate. And what is gate and what is NOT gate, you will learn these terms into the next week. So let's move into the next slide. And from this slide you may learn one of the example of ones complement. So let's start with the question. Example 1, find ones complement of 1010110. So let's start with the solution. Given binary number is 10101110. So we already know if we find out a given binary number one's complement, then just invert that number. So what is meant by that? Look at the given binary number. Start with the 10101110. If we invert the leftmost number, which is 1, if we invert, we get 0. The next one, 0, if we invert the 0, then we get 1. I hope you understand. This way rest of the digits or rest of the numbers are same. So I hope you understand how to convert one's complement of a given binary number. So let's move into the next slide. From this slide we may learn about 2's complement. So let's start. There is a simple algorithm to convert binary number into 2's complement. To get 2's complement of a binary number, simply invert the given number and add 1 to the least significant bit of given result. Implementation of 4-bit 2's complementation number is given as following below. If we look at this figure, then you may notice the upper portion of this figure are familiar with you guys, because in previous slide in this lecture you get the one's complementation 4-bit logic circuit, and the upper part of this circuit of this representation is the one's complement, and then we need to add 1. So let's move into the next slide. From this slide you may learn the example of 2's complement. So let's start with the example. Find 2's complement of 10101110. So let's start the solution. First we need to write given binary number, which is 10101110, and we already know we need to convert the given binary number is or into 1's complement. So if we convert the given binary number is 1's complement, then we get 01010001. Then the overview 2's complement says we need to add 1 binary number in the LSB. Well, so that's why in the third row of this table you see 1 binary number is added in the LSB. So we get 110, then 1 plus 0 1 0 0 1 0 1 0. So this is the way to convert 2's complement of a given binary number. So let's move into the next slide. So in the next lecture you guys will know about the logic gates. So let's move into the next slide. So that's all for this lecture. Thank you so much for your attention. See you guys in the next lecture, and thank you.